3 of May. Is there any problem, schedule conflict? Because we already have this time slots available. But if you have a problem, then I can switch to another day. So please let me know if you have a problem. Okay, then any other questions? We can go on to schedule on ship design procedures. Radim will lead us to explain about. Right, go ahead.
Okay, so today I want to talk about how to design a ship. And I know that there are a lot of different types of ships and also a lot of different procedures we have to go through when designing a ship. And before we go on to talk about hull forms or static stability or dynamic stability, we first want to revise or review the design procedures that we have to follow. And these mainly consist of economic factors as well as business related factors, as well as mechanical factors, to give you an overview of how a ship is supposed to be designed. So let's go on. We have a very comprehensive diagram, a schematic here, showing how shipbuilding is actually an integrated technology. It has production, commissioning, delivery, planning and control, engineering design, stock and logistics. And you see that design is not simply design as you do on a drafting table on itself, but it is consisting of a lot of different chains of people. It's a kind of multifaceted arrangement where a lot of different sectors have to always constantly collaborate together. And we call this whole process a very integral part of shipbuilding and design. And there are basically two main phases that you have to consider when creating a ship design. Initially, we have creative type design, which is composed of generating and testing the model, and also analyzing, which is analytical. It basically talks about how you should design and analyze a given design. And when we talk about design, shipbuilding, and also in general, there is no single correct solution that exists in engineering design. You have to kind of create a model and so you have to create a model, and there are many different models that you can apply for a system. There are good models, acceptable models, and optimal solutions, but you cannot pinpoint a certain design for a ship to be the best design that exists, because there are a lot of different alternatives depending on your creativity or preference or aesthetics, or depending on what different kind of function you want to add to your design, as long as you meet the engineering design requirements. But what is important is that when it comes to analysis, there is a single correct solution. So when you build a structure, you have to consider structure factor, weight, and also your budget, given budget. You cannot have a different solution, or you have to calculate something mechanically, the pressure, collapse, hydrodynamics. You may be wrong or maybe unaware of the correct solution, but there is always a single correct solution when you have to properly analyze a given design. And you see that there is like a sketch of a ship, and how do we change this basic elementary sketch into something that is more real and actually into a real ship that you use? You usually have to follow a certain thing called a design timeline. And when we regard a design timeline, in the initial stage, we have a large amount or a large degree of freedom to make change. But as time goes on, this freedom decreases and we have a larger front load, you realize. And we need to have, as the timeline goes on, a lot of viewpoints about how design knowledge is implemented and also how much cost is spent. And secondly, we have to consider the ship design spiral. We have learned about different types of ship design spirals in the past lectures. And in our mission requirements, we start from 4 different types of design concept design phase, preliminary design phase, contract design phase, as well as detailed design phase. These phases are required to realize our certain design into an actual given product. So what is also interesting is that these 4 phases, as you go on deeper and deeper into the center of the spiral, you get more and more specific. So it's from a broader point of view, from a more specific point of view, as you go on into the detailed design phase. And what is also interesting is that these 4 different colors, concept, preliminary, contract, and detail, they all take different amounts of time, which means that different amounts of time and manpower are usually allocated to these 4 sectors. Now we'll talk about embodiment design, and when it comes to deliverables, we consider main dimensions and capacity. We learned about GA and preliminary lines, midship section drawing, also some very hydrodynamics when it comes to buoyancy or weight calculation, as well as some collaboration with like electrical engineers, because we have to consider electricity, as well as some process engineering when we have to consider costs, as well as like production hours and production process. So this is a very nice video that shows you about ship design economics. Yeah.
그리고 저 링크를 카피해서 갖다 붙이고 파워포인트에서 그 목사. 검색창에다가 그다음에 유료 버전은 저걸 켜놨는데.
Smooth sailing or rough seas ahead? How is your company navigating today's maritime economy? Has the combination of environmental regulations, shifting customer demands, and increased global competition created the perfect storm? The only way to weather that storm, to ensure safety and sustainability compliance, reduce development time, costs, and risks, and stay afloat in an uncertain market is to harness the power of digitalization. With the world asking for better, faster, smarter, and greener vessels, a sea change is needed from the start of every new project. Use digitalization to propel change and boost innovation with integrated ship design and engineering. Remain in control of the design spiral by bringing all your multidiscipline design processes into one integrated environment, from initial design to production design. Improve collaboration and end-to-end process execution by creating a digital twin of your vessel. Use it as the single source of truth to manage all its mechanical, electrical, and software features. Discover better designs faster with simulation-driven ship design. From the very start of your project, understand, explore, optimize, and test any aspect of ship performance, from individual components to full systems. Break down the silos in your current approach with better process orchestration. Increase overall enterprise productivity by managing requirements, traceability, weight, configuration, and the EBOM in a centralized environment. Adopt an integrated approach to ship design and engineering and get ready to go full steam ahead on the seas of tomorrow. Siemens.
Okay, so this video was showing how like a certain company was very providing nice solutions for design processes. Okay, now we'll go on to talk about engineering economics So the aim of engineering economics is to make an investment as rewarding as possible, as it goes with other types of economics as well. You always have to create a certain amount of like investment, and the output has to be having the maximum efficiency. There is something that we call a return on investment, also known as ROI. And ROI is the ratio between the net income and investment. It is the metric to measure the rates of return on money invested in a certain economic entity to decide whether or not to undertake an investment. If you do the stock market, you would know that you would really want to reduce the amount of money you initially want to invest and invest with the maximum amount of efficiency. The key concepts that are explained here are the money does you no good until it is spent, and also discount future cash flow. Discount future cash flow refers to the valuation method, which is used to estimate the value of an investment based on its expected future cash flows. So this is kind of like what you use what you know today to use it to predict something that happens in the future. It's kind of like a model to predict what is going to happen in the future, kind of like a simulation in a way. So this is actually another video that shows you about how discount future cash flow is going on. But I guess I'll skip it because I don't think we'll have enough time, but I really recommend you to watch. Maybe if we have time, we could watch it later. But it talks about how basically it is a future projection about how cash flow is oriented. And it is kind of like a scale, a weight scale that shows you how future cash flow can be calculated or predicted or estimated. Now we'll talk about required freight rate. Now, freight rate it's the rate payable in the free markets of a war for the transport of units of specific types of goods. So for example, you have a certain type of cargo or oil or a material that you want to transport, which is known as a good. And it is can be calculated as the rate that you want to pay in a certain type of free market for transport. Another type or another derivative of freight rate is called the RFR, or the required freight rate. And it is used to measure something very similar, the minimum cargo rate, which the ship owner has to charge the customer just to break even. So what's the main difference between the FR and the RFR? Well, the RFR can be conveniently calculated by dividing the average annual cost, also known as the AAC, into the cargo capacity. But for example, when you are operating a crude oil carrier between the Persian Gulf and Busan to a port of Korea, it's going to be kind of difficult to predict the actual FR if you're an engineer, if it's given to you as a problem. But if it's an RFR, you can just use this calculation I gave you. You just divide AAC by cargo capacity, and it'll give you a very easy and convenient and viable method to use to calculate or predict the amount of money you have to pay. This implies that the best ship at any given trade is the one that can offer a minimum rate while still producing reasonable profits. So it's also all about efficiency when we're designing a certain type of ship. So you have to produce something with the maximum kind of effort, or at least reasonable effort, by offering a minimum amount rate. And I want to introduce you to another type of criteria that is being used in the industry, which is known as capital expenses and operating expenses. The names by themselves give you a certain idea of what these criteria might be. And to give you a deeper understanding, basically CAPEX or CapEx, capital expenditure, is like a company's major or long-term expenses that you invest for your future. But operational expenditure is something that you or a company use on a day-to-day basis. So capital expenditure is like physical assets, large structures, buildings, machinery, or all those kinds of stuff that you have to pay along. But day-to-day expenses are more like salary or like goods, and they are more like they can be deducted from taxes. So you get the basic idea about the difference between like a major or long-term expense to a day-to-day expense of an everyday company might be. Here's a simple example showing the different criteria. There are actually different types of ships, commercial ships or naval crafts. They all have different criteria and different necessary inputs that are being used for each type of criteria. And you notice that for AAC, it's not commercial, but other types of ships are being used mainly because, as we saw, like AAC, it doesn't really require like cargo, although people could be considered as cargo. It doesn't really have the same meaning as we do when we transport goods or cargo. And you notice that for these like AAC and RFR, you don't really have to input an annual revenue. While for the other types of criterion, you have to input annual revenue. Instead, we have to consider what we just talked about, capital expenditure and operational expenditure. Oh, and next I want to talk about Baltic Dry Index. I'm actually pretty bad at economics, but I found this pretty interesting because it's an index of average prices paid for the transport of dry bulk materials across more than 20 roads. And it's kind of like how you can predict an economic activity of why a certain material or could be very effective or very popular or very like scarce in manufacturing, or why the global market is moving around in a certain place. So it just doesn't give you the price for itself, but it could just give you a very large scale viewpoint about how the market and the whole world is like moving. So I think it's kind of interesting. So I wanted to show you this real-time analysis on the BDI. So BDI is like a kind of a website. It's a website that shows you the direct like how things are really moving around in the market. Okay, so if you look at this graph, you have the exact point for today, and you could just move on in like the graph or like zoom in and zoom out and move back and forth to see how like whole history has been going on for the entire index. So you can also check how like different types of like materials have been changing, so on and so forth. And it's pretty interesting because like you could also check for a wide range of different materials. For example, there are materials related to energy like gasoline or like coal or ethanol, and also metals. And a lot of like you might be interested in agriculture, the food that we eat, for example, well, like cheese, like orange juice and coffee and everything we use today. We could like view how like these different materials are being like how their price is going on, how their index is changing at a very constant level, weekly, monthly, and yearly and daily. And what I found pretty interesting was that, well, I'm quite interested in like materials. So there is a very like large increase in the lithium from like year to year. So I kind of thought about it and did a bit of research on it. And it appears that like lithium is actually, I have to kind of, okay, so it's like actually like these lithium is like increasing rapidly, you see, because of like EV policies and transition to electrification in recent years. So all of these like lithium batteries and a lot of like interest publicly on like electricity instead of like coal or fuel has caused a nearly a large drastic increase, a dramatic increase in the amount of lithium, which was something that I noticed in well, like surfing through this like website and found pretty interesting. So this is just one example about how one like a certain material could increase in popularity or demand, and you can use the Baltic Dry Index to learn about how like these different manufacturing materials are being transported across the sea and how the global economy is really moving in a fluid manner. And the design environment, you have to consider other types of parameters such as international regulations, rules, and other bases, and actual things that you have to consider in reality. So it's kind of like a difference between your idealistic manner of approaching a problem and your realistic regulations that you have to abide to when actually designing a ship or a process for a ship. So this is another example about marine engine regulations. it gives you a good idea about what kind of regulations you would be actually facing when you're designing a ship. For example, even if you like design a ship that's like perfect in terms of functionality or aesthetics, if you have a large amount of like NOx or SOx emissions or environmentally polluting substances, you're going to have to change your design or revise your design depending on your system. And you can see that the rates of sulfur, because like environmental awareness has been like increasing throughout the century, it's been like decreasing throughout the centuries, and it's being prospected to like decrease in the future, which is a positive thing. So yeah, this is kind of like the practical regulations you have to consider for like actually designing a ship. So in summary, design decisions should be based on economic analysis as well as subjective judgment and experience, as well as a little bit of statistics you want to refer to. So you have to consider science, art, as well as other comprehensive factors to design an actual ship. So it is crucial, although we are engineers, to understand how economics is related to the field of design and help make good decisions in ship design. Yeah, thank you for listening to the presentation. Yeah, there are also some appendix slides.